Hello everyone, welcome back. This is RMO 2025 P4. Let's read the problem statement. Okay, so the problem is saying prove that there do not exist positive rational numbers x and y such that x plus y plus 1 by x plus 1 by y is 2025. So the natural thing to do here would be, of course, you just take x is equal to a by b and y is equal to c by d. And yeah, I'll take these to be in the lowest forms, where lowest forms just means that the GCD of A, B is 1 and the GCD of C and D is 1. Okay, and now we sum this up and the problem is saying that this sum is equal to 2025. Okay, cool. And now I'll just expand this out because why not? Expansion is always great. And expanding this will give a squared CD plus b squared CD plus c squared AB plus d squared AB. So this is some nice expression because this is good and this is good because we can combine them, and this is equal to 2025 times A, B, C, D. And okay, so I'll pair these up and I'll get a squared times CD times a squared plus b squared plus AB times c squared plus d squared is equal to 2025 times A, B, C, D. And this is an equation not over positive rationals. This is just an equation over positive integers because A, B, C, and D are all positive integers. Should probably have mentioned that, but yeah. Okay, so what does this mean? So the first thing I notice here is that AB divides this because it's a multiple of AB. Right? AB divides this, and AB also divides this because AB is over here. So AB should divide this. So we get AB divides CD times A squared plus B squared. But this is actually really good for us. This is actually really good for us. Why? Because AB and A squared plus B squared, these two numbers are co-prime. Why are they co-prime? They're co-prime because GCD, actually the other way around, they're co-prime because GCD of A comma B is equal to 1. Right? So since AB and A squared plus B squared are co-prime, what we get is, we can just cancel this off, and what we get is AB divides CD. But this is even better because this is completely symmetric. This expression is completely symmetric, and similar to what we did with AB, we can obtain that CD divides AB times C squared plus D squared. And again, CD and C squared plus D squared will be co-prime since C and D are co-prime. So we get CD divides AB, right? So this and this combined, since we are only working over positive integers and we don't have any sign issues, this just together gives us AB equals CD, which is very, very good. Why is it very, very good? Because now I can just plug in AB is equal to CD over here and over here, and what I get is AB times A squared plus B squared plus AB times C squared plus D squared is equal to 2025 A squared B squared. And I can cancel off the ABs, which is wonderful. And what I get is, I'll use another color. Okay. What I get is A squared plus B squared plus C squared plus D squared is equal to 2025 AB. Cool. That's cool. And here we can just finish. We can just finish straightforwardly because we can take modulo 3. We can take this equation modulo 3. This just becomes 0 because 3 divides 2025. And we get A squared plus B squared plus C squared plus D squared is congruent to 0 mod 3. And remember that we know AB is equal to CD. So this equation only has the solutions modulo 3 for ABCD. The solutions that it has are 0, 0, 0, 0. We are using the fact that the only squares modulo 3 are 0 and 1, by the way. because 0 squared is congruent to 0 mod 3, 1 squared is congruent to 1 mod 3, and 2 squared is also congruent to 1 mod 3. So the only possibilities for this equation to hold will be that A, B, C, D are congruent to 0, 0, 0, 0, or they're congruent to 1, 1, 1, 0. Like this is A squared, not A, sorry. So A squared is congruent to 0, B squared is congruent to 0, C squared is congruent to 0, D squared is congruent to 0, or A squared is congruent to 1, B squared is congruent to 1, C squared is congruent to 1, D squared is congruent to 0. So that's cool. Now there's an issue with this case. There's an issue with the case where all of them are 0 mod 3. Why? Because A squared congruent to 0 mod 3 means that A is congruent to 0 mod 3, which means that 3 divides A, and B squared congruent to 0 mod 3 means that 3 divides B. However, we know that A by B is a fraction in the lowest terms, so this is just incorrect. This just can't be possible because GCD of A comma B is supposed to be equal to 1. So this case is eliminated, and now the case left is A squared congruent to 1 mod 3, B squared congruent to 1 mod 3, C squared congruent to 1 mod 3, D squared congruent to 0 mod 3. So C squared is 1, D squared is 0, D squared congruent to 0 mod 3, as we've already confirmed, means that D is congruent to 0 mod 3, right? Because these are the only cases. So D is congruent to 0 mod 3, which means that CD is congruent to 0 mod 3. Okay. But now, remember that we know that AB is equal to CD from before. So this means that AB should also be congruent to 0 mod 3. And since 3 is a prime, this means that A is congruent to 0 mod 3 or B is congruent to 0 mod 3. But clearly, since we have something like this, we have A squared is congruent to 1 and D squared congruent to 1. Neither of them is 0, so we have a contradiction. And note that all of the other cases of the form, they'll look like 0, 1, 1, 1 or 1, 0, 1, 1 or 1, 1, 0, 1. They'll all just be handled similarly because the main point is really just that there's only one square congruent to 0 mod 3 in all of these cases. Alright, so this case is invalidated and similarly all of these cases are invalidated. Thus, we don't have any cases left, and indeed, there do not exist positive rational numbers x and y such that this condition holds.